Okay, let's dive right into this explainer. Today, we're unpacking a story that literally sent shockwaves through the tech world recently. We are looking at the fascinating and frankly kind of terrifying intersection of artificial intelligence and cryptocurrency security. We're going to separate the science fiction from the actual mathematical reality and figure out what it all means for the safety of our digital assets. So, imagine being completely locked out of your own digital fortune for 11 straight years. Well, that's exactly what happened to an ex-user known as CPR Arn. But the crypto world was absolutely stunned when they claimed they finally cracked the password and got back in, all with the help of Claude AI. You can imagine the headlines, right? Pure panic. AI has hacked Bitcoin, was spreading like wildfire. But when we actually peel back the layers here, the truth is way more nuanced and honestly way more interesting than a simple hack. And we are not talking about pocket change here. This locked digital vault held 5 Bitcoin. Based on the market price at the time, that's equivalent to over 3 million Hong Kong dollars. So when the public hears that a widely available AI just casually popped open a multi-million-dollar digital safe that had been sealed shut for over a decade, yeah, it naturally sparks a systemic panic. It makes us all ask, are any of our digital assets actually safe anymore? Well, here is the ultimate reality check. The AI absolutely did not break Bitcoin's SHA-256 encryption. Not at all. That mathematical vault door remains completely undefeated. It's still the absolute bedrock of crypto security. What the AI actually did was simply help reconstruct a forgotten password by piecing together a messy trail of human clues. So AI didn't defeat the math. It defeated human nature. Moving into Section 1, AI as a digital archaeologist. That brings us to this quote. The safe is still strong. The weakness is human memory. Honestly, that pretty much hits the nail on the head. The math behind the blockchain is ironclad, but us, humans, we have a terrible habit of being incredibly predictable. We base the passwords to our life savings on our pet's name, significant dates, our favorite obscure words, or just repeated formatting habits. That human predictability, our reliance on emotional context, is exactly the crack the AI exploits to get past the lock. To really grasp the massive leap in capability here, think about the old way of cracking a password versus the new way. A traditional brute force attack. It's basically like a blindfolded person trying every single physical key in existence. It's wildly expensive, painfully slow, and totally blind to the actual person who made the lock. But AI-assisted reasoning, it takes the blindfold off. It analyzes your personal context and your digital habits to create a highly targeted shortlist. It doesn't bother trying every key, it only tries the specific ones it deduces you would actually use. It's wild when you see how an AI parses this human chaos. By feeding an LLM a fragmented, decade-old diary, it instantly extracts these structural insights. It sees recurring words like memory and police and recognizes them as important themes. It spots the year 2014 as a likely numeric suffix, or notes a user's specific preference for using underscores instead of dashes. Then it synthesizes all these scattered clues into highly plausible passwords, like memory underscore police underscore 2014. It literally turns years of messy personal history into a prioritized hit list. Now, you might be thinking, wait, sending my most intimate data to a cloud-based AI sounds like a massive privacy nightmare. And you'd be right. To do this safely, developers use a local simulation workflow. The AI is only ever supplied with sanitized text hints. It never touches your real wallet files, your seed phrases, or your actual private keys. The LMN's only job is to brainstorm the guesses. The actual verification, that's run strictly on a secure offline mock wallet running locally on your own machine. Okay, Section 2, connecting AI to wallets. So if we aren't sending private keys to the cloud, how are developers formally bridging the gap between these intelligent AI agents and secure cryptographic environments? The secret sauce is the Model Context Protocol, or MCP. Think of an MCP server as a secure, soundproof glass box. It allows an external AI assistant like Claude to look inside and interact with an Ethereum wallet toolkit. The AI can execute commands and read data entirely offline within that controlled space, without ever being able to take anything out of the box or send it back to the internet. Because these MCP servers operate entirely offline with absolutely zero network calls, the AI transforms into a hyper-secure crypto assistant. It handles all the heavy cryptographic lifting locally. We're talking generating random wallets, decoding complex key stores, and building complicated blockchain transactions without you needing to memorize code. And since it's completely localized, it processes all these raw operations while ensuring your private keys never, ever touch the open web. This reliance on customization brings us to Section 3, the vanity address vulnerability. $160 million. Just let that number sink in for a second. That staggering sum is what the crypto market maker Wintermute lost in a single hack back in 2022. And the craziest part? It wasn't a sophisticated phishing scam or a rogue employee. It happened simply because they wanted a customized vanity address with leading zeros to save on gas fees. And the third-party tool they used to create it was completely compromised. So what went wrong? Well, the open-source address generator they used, called Profanity, had a fatal flaw: a terrible random number generator. Imagine thinking you bought a massive bank vault secured by a 256-digit combination lock. But because of a coding error, the lock actually only has 4 digits. That's essentially what happened. It reduced the mathematical complexity so drastically that attackers didn't even need supercomputers. They just used standard computer graphics cards to recreate the private keys in a matter of hours. The security researcher known as Fubar summed up the danger here perfectly. EOA vanity is the road to bankruptcy. Smart contract vanity is the road to success. The technical method you choose to generate a vanity address literally dictates your survival in the crypto space. Basically, if you want a custom vanity address for branding or saving on transaction fees, using a standard externally owned account is incredibly unsafe if the key was generated through brute forcing software. You're playing with fire. The safe alternative is deploying it via a smart contract factory. By using specific coding commands like create_to, you're essentially using a secure digital vending machine to generate the address deterministically. You get the cool custom look you want, completely without compromising your core cryptographic security. Let's wrap things up with Section 4, securing your digital vaults. If you think you're perfectly safe just because the underlying cryptography is strong, consider this. A single victim recently lost $72 million in wrapped Bitcoin. The math didn't fail them. Instead, they got hit by something called address poisoning. Scammers basically generated a fake wallet that perfectly mirrored the first and last few characters of the victim's real wallet. By dropping a tiny fraction of crypto into the account from this fake address, they completely tricked the victim into accidentally copying the wrong address straight from their own transaction history. So, to defend against both AI contextual guessing and scammers mimicking your wallet, you have to completely remove your own human habits from your defense strategy. Use purely random passwords generated by a password manager. Absolutely no pet names, no birth years, no recognizable patterns. Keep your seed phrases strictly offline. That means absolutely no photos saved on your phone's camera roll, seriously. Rely on hardware wallets for the heavy lifting. And crucially, always verify the entire address string when sending funds, not just the prefix and suffix. So, as we wrap up this explainer, I want to leave you with one really crucial question. Ask yourself, if an AI digital archaeologist started digging through your past, your old notes, your diaries, your digital footprint, would they find the keys to your financial future? Keep your cryptography mathematically strong and keep your human context entirely out of your vault. Thanks so much for joining me on this explainer.